Okay, to convert 142 centimeters to kilometers, I'll show you a general setup you can use because sometimes with units, things will get confusing. There'll be a lot of different conversions happening, so it's good practice to be in some sort of like mode where you're doing the same thing every time. That way, you have a strategy that works even when things get really complicated. It's pretty simple. What you want to do is take the units you're given. The starting amount is 142 centimeters, and then multiply by some sort of conversion factor. Okay, so kilometers. If you remember, if you go back and look it up online, kilometers to centimeters. Okay, 1 kilometer has 100 meters in it. Okay, and then 1 centimeter is just 0.01 meters. So these are like powers of 10 that you go up in the table. Okay, to get from centimeters to kilometers, there's 10, there's 100, there's 1,000, there's 10,000, there's 100,000 centimeters in 1 kilometer. Okay, so I started at the unit I was at centimeters. I want to convert centimeters to kilometers, so I count by tens. 10, 100, 1,000, 10,000, 100,000 centimeters in a kilometer. So I'm going to multiply this by 1, okay? Something divided by itself is 1. Two equivalent things being divided makes 1. So 1 kilometer is 100,000 centimeters. So I'm not really changing the problem I was given in Newton, right? And the reason why we do it this way is because, if you put this over 1, made it a fraction, the centimeters would cross cancel. So you should be looking for that cross cancellation to happen. So now we have 142 divided by 100,000 kilometers. Okay? So 142 divided by 100,000 gives us 0.00142 kilometers. Okay? So do not round your decimal answer. Do not include units. 0.00142. Let's see what else they got for us. Oh, nanometers. I don't know if I wrote down nanometers. I'm pretty sure nanometers is 1 meter times 10 to the negative ninth. But what we can do, we can look that up in just a second here. Just takes a quick Google search. But okay, so we got the diameter of a helium atom, 0.1 nanometers. What's the diameter in millimeters? So we can just search nanometers to, could do it to meters, but nanometers, I think it said millimeters, right? Yeah. So it's 1 e to the negative 6. What that e means, it's 1 times 10 to the negative 6 power. So that e you see in your calculator is shorthand for scientific notation. Okay, so to make 1 times 10 to the negative 6, to look at that as a plain old number. Okay, the negative 6 power means you move the decimal 6 places to the left because negative 6 that means you're shrinking it. Okay, so 1, 2, 3, 4, 5, 6. So we can fill in zeros in between each one. So the decimal right here. 0, 0, 0, 0, 0, 1. Okay, so 1 nanometer is, oh, sorry, this is how many millimeters, 1 nanometer. So now we got a conversion factor, okay? 1 nanometer is 1 times 10 to the negative 6, or in other words, 0.000001 millimeters. Okay? So now we can make this conversion. Now they have 0.1 nanometers that we're supposed to convert. I'm pretty sure nanometers is nm. I should look that up. Yeah. I don't remember all the abbreviations, and I don't remember nanometers off the top of my head. But so yeah, 0.1 nanometers. To convert that to millimeters, we got to multiply it by this conversion factor to make the units cross cancel. Okay, so we said we have to multiply it by 1. So we're going to use 0.000001 millimeters over 1 nanometer. That way, we have our units cross cancel. Okay, these will cross cancel. And so if you're multiplying 0.1 times something, it means you're just tacking on an extra 0 after the decimal because you move it one place back. So we got 0.0000001 millimeters. And they say don't use units. Okay. Okay, SI units, in case it's the first time seeing it, it's the international standard units. Okay, like meters is the standard unit for measurement. In the USA, we use I forget what they call it. I think they call it the English system, or no, that might not be right. But in America, we usually use like Fahrenheit and inches and pounds. But the standard unit of measurement is grams instead of pounds, meters instead of feet, things like that. So, uh, measuring the force it takes to push a safe. Okay, force. If you look up the formula for force, if you haven't taken physics or something like that, force is mass times acceleration. Okay, so force is mass times acceleration. Mass is easy. We know what the units for mass is. It's grams in SI. Okay. Now acceleration, it gives you the units right here. Okay, meters per second squared. Okay. Velocity and acceleration are really related, right? Velocity means like how fast you're going. We say like we're going 60 miles per hour in the car. So acceleration is how fast the velocity is changing. So acceleration in SI units is meters squared. Meters divided by meters per second squared. I said that incorrectly. Okay, so this is grams, or it could be kilograms, or something in the SI units, times acceleration, which is meters per the SI unit of seconds squared. Okay. So let's see what we got for options here. We got grams, which could be kilograms. Okay, kilograms times meters divided by seconds squared. That's the one that matches what we have here when you make it one big fraction, right? So some of it will be, if you haven't done physics before, you'll have to look up those formulas. So when measuring the amount of water in a tank, okay, I'll leave this one for you guys, but think about how you measure volume, okay, what type of units you use for volume, and you can obviously look that up.